Half an inch. That's roughly how long the fatigue crack was the last time the disc sat under ultraviolet light in a United inspection booth. It passed. On July 19, 1989, the number 2 engine on a United DC-10 came apart over Iowa. The Stage 1 fan disc in that engine had been through fluorescent penetrant inspection several times at United's own overhaul facility. It passed every time. The inspection that was supposed to catch it left its own residue inside that crack, and the disc was passed anyway. This is a story about a flaw born in a foundry and about what it takes for a human being to see one. Start with the hardware. The DC-10, Model 10 that day was N1819U, and its number 2 engine sits in the tail, buried in the vertical stabilizer with the intake above the fuselage. That engine was a General Electric CF6. At the front of it, spinning behind the fan blades, is the Stage 1 fan disc. Think of it as the hub the fan blades are anchored into. It carries enormous rotational load, and if it bursts, the casing around it can't reliably contain what comes off. That's the term you need, uncontained failure. Engines are designed so that when a blade sheds, the case around it absorbs the energy and keeps the debris inside the nacelle. A fan disc is a different problem. It's a heavy, high-energy rotating structure, and when it fractures, pieces leave the engine at speed and go wherever their trajectory takes them. Containment stops being a promise once you're talking about a disc. That's why discs are treated as life-limited parts with tracked cycles and mandated inspections, and why the metallurgy that goes into them is controlled so tightly. The whole safety case for a disc rests on it never cracking in the first place. Now the second half of the design. Hydraulic redundancy means the airplane carries multiple independent hydraulic systems, so a leak in one doesn't cost you control. The DC-10 had three separate systems, 3 sets of pumps, 3 sets of lines, powering the flight controls that actually move the airplane. On paper, that's deep redundancy. The 3 systems were independent in every way except geometry. Their lines all had to pass through the tail, within a few feet of the number 2 engine. Redundancy on paper, one shared neighborhood in the airframe. That's exactly what happened. According to the NTSB's final report on the accident, report number AAR9006, the Stage 1 fan disc in the number 2 engine separated in flight. The failure was uncontained. Debris from that disc severed all 3 of the airplane's hydraulic systems. Every powered flight control on the DC-10 lost its pressure. The crew was left with the 2 remaining wing engines and differential thrust as their only means of maneuvering the airplane toward Sioux City. Everything that followed in that cockpit traces back to one component and one crack inside it. So where did the crack come from? The NTSB traced it back to the manufacture of the disc itself. The titanium contained a metallurgical defect, an internal inclusion, essentially a hard, foreign region of material that never belonged in the finished forging. That inclusion became a stress concentrator. Cycle after cycle, every time the engine spun up and back down, a fatigue crack advanced from it. Fatigue cracking is patient. It moves a microscopic amount per cycle over years of service until the remaining material can no longer carry the load. That defect reached the bore of the disc, and the crack grew from there. The disc bore is the inner surface of the central hole, the one that fits over the engine shaft. It's one of the highest stressed regions of the whole part because that's where hoop stress concentrates as the disc spins. A crack originating there is about as bad a location as you can pick, and the bore is the piece of geometry this entire story turns on. Here's how the inspection works. Fluorescent penetrant inspection, FPI, is a surface crack detection method. The part gets cleaned, then coated in a fluorescent dye that seeps into any surface-breaking flaw by capillary action. Excess dye is washed off, a developer is applied to draw the trapped dye back out, and the part goes under ultraviolet light. A crack shows up as a glowing line against a dark background. It's sensitive, it's well proven, and it's used on turbine components across the industry. It also has one absolute requirement at the end of the chain. A human being has to look at the part and register the indication. The disc had been through FPI several times at United's overhaul facility during its service life. Investigators found a discolored region on the fatigue fracture surface, 12.1 millimeters long, which the safety board concluded was most likely left by the last penetrant inspection. That's how they sized the crack at 1/2 inch when it was last under the light. The disc hung on a line that passed through the bore while it was inspected, and the safety board concluded a crack that size should have been readily detected. But the procedure in use gave the bore no special attention, and after the accident, the FAA required fluorescent penetrant procedures that specifically covered titanium fan disc bores. That's reflected in the probable cause. The board cited inadequate consideration of human factors limitations in United's inspection and quality control procedures. Read that carefully. The board is describing the system, not the technician. One person, one pair of eyes, one dark booth between a growing crack and a flying airplane, and an assumption that would be enough. So the fix ran in two directions at once. The FAA required penetrant procedures that specifically addressed the bores of titanium fan discs, closing the gap in what the process demanded of that surface. And the FAA convened a review team on titanium rotating components, which pushed the industry toward tighter control of the penetrant process itself and better support for the people running it. That's the pattern behind most of the inspection procedures you'll ever sign off on. Somewhere upstream of the rule sitting in your task card, there's a report with a date on it and an airplane that didn't finish its flight. So next time you're at the booth, don't just ask whether the procedure covers the part. Ask what conditions you're being asked to see under.